Introduction: commercial air conditioners remain expensive and inaccessible for many people. This guide will walk you through building your own homemade air conditioner using simple, affordable components. You'll create a functional miniature cooling system capable of reaching temperatures as low as -10 degrees Celsius. Part 1. Manufacturing the gas evaporator unit. Begin with a 4 by 6 mm copper tube. Find something cylindrical for bending. A standard paint can works perfectly. Carefully wrap the copper tube around the can, applying steady pressure to create smooth, consistent spirals. Form approximately 8 complete turns. This spiral configuration maximizes surface area for optimal heat exchange. Copper's exceptional thermal conductivity makes it perfect for this application. Cut the tube after 8 turns and gently bend both ends outwards slightly for easier connections later. Part 2. Manufacturing the gas condenser unit. Using your remaining copper tubing, construct a condenser circuit. Create a slightly wider spiral with fewer turns than the evaporator. The condenser releases heat collected from inside your cooling space to the outside environment. The wider condenser coils provide increased surface area for heat dissipation, while the tighter evaporator coils maximize cooling concentration. Part 3. Mounting components on wooden base. Select a wooden board as your base platform. Pre-drill holes according to your component layout. Install plastic support brackets to secure both copper coils. Mount the evaporator first, using cable ties to fasten it firmly against the mounting brackets. With the evaporator secured, mount the condenser nearby. Pay close attention to inlet and outlet tube orientations. Proper alignment prevents connection difficulties later. Part 4. Manufacturing and installing the capillary tube. Select a narrow gauge copper capillary tube. This component creates a sudden pressure drop within the evaporator, triggering rapid evaporation and intense cooling. Wrap the capillary tube around a pen to create 2 or 3 tight coils. Insert one capillary end into the condenser outlet and the opposite end into the evaporator inlet. Flatten both connection points slightly and solder both joints completely. Thorough sealing prevents refrigerant escape. Any leak compromises system performance. Part 5. Electrical component installation. Attach a small 12-volt fan to the wooden base, positioning it directly adjacent to the evaporator coil. This placement ensures maximum airflow across the cold evaporator surface. Install a battery holder onto your base platform. Next to it, mount a holder for your air pump. Cut PVC pipe into appropriate lengths to create connection pathways between condenser and evaporator outlets. Position the 12-volt air pump securely in its designated holder. Connect pump outlet to condenser inlet and pump inlet to evaporator outlet. Complete electrical connections by wiring both air pump and fan to your battery terminals. A standard 9-volt battery provides sufficient power for testing. Test your electrical connections. The pump should activate immediately when battery power is applied. Part 6. Understanding the refrigeration cycle. Your homemade air conditioner operates on fundamental thermodynamic principles. The refrigeration cycle relies on a simple concept: using phase change to move heat from one location to another. Isobutane serves as our refrigerant. When isobutane transitions from liquid to gaseous state, it requires energy, specifically thermal energy. This energy is drawn directly from surrounding air molecules. Step-by-step cycle breakdown. Evaporation phase. Liquid isobutane enters the evaporator through the capillary tube. The sudden pressure drop causes rapid evaporation. This phase change consumes enormous heat energy, extracted directly from evaporator tube walls. The copper conducts this cold efficiently, creating sub-zero surface temperatures. Heat absorption. As fan-forced air passes over these freezing coils, heat transfers from air to tube surface. Air temperature drops dramatically. Compression phase. The air pump collects low-pressure gaseous isobutane from the evaporator outlet. Compressing this gas raises both pressure and temperature significantly. Condensation phase. Hot, high-pressure gas enters condenser coils. Being warmer than ambient air, heat naturally flows outward. As gas releases thermal energy, it returns to liquid state, ready to repeat the cycle. This continuous loop creates sustained cooling capable of lowering room temperature within minutes. Part 7. Refrigerant charging and testing. Using a standard syringe, carefully introduce isobutane into your sealed circuit. Work slowly to avoid introducing air bubbles or overfilling. Connect your battery and observe system startup. Within moments, frost forms along evaporator coils. Surface temperatures plummet rapidly, reaching -7 degrees Celsius during initial measurements. Allow continued operation. Temperatures drop further as the system stabilizes. Our testing confirms sustained performance at -10 degrees Celsius. The fan delivers continuous cold air streams, providing genuine cooling relief. Conclusion. This DIY air conditioner demonstrates that effective cooling solutions need not require expensive commercial equipment. By understanding basic refrigeration principles and utilizing readily available components, anyone can construct a functional cooling system. We invite you to share your own DIY cooling projects and improvements. Your innovations help advance accessible cooling technology for everyone. Acknowledgements, special thanks to our channel members whose support makes these educational projects possible. Remember to subscribe, activate notifications, and consider membership options to support future content. Thank you for watching and happy building.